So now we're going to talk about closure. And closure is a concept of we want to enclose the scope of a variable and contain it to a certain area. So we're going to enclose some code around that variable so that that scope of that variable is limited. So that's closure. We're enclosing a variable in some code so that that variable's scope is limited to that one area of the code. That's closure. We're enclosing a variable so that we limit its scope. Limiting scope is like one of the high arts of a Zen Jedi code master, is you want to just keep the scope of your variables as narrow as possible. And so just to kind of give you an idea of scope, like here's package level scope, var x int. That's package level scope, and I could print x out, x, and just copy this a couple times and run it, and it's going to print it out. If I had x++ here, all right, run it, there we go. And the scope of x is this entire package. I could have a function down here, right, that like just does whatever. And then it could go x++. And if I call foo, right, like the scope of x is this whole package. So x is here at 0, we enter main, we print out 0, we increment x to 1, we print out x, so 1 prints out right there, and then we call foo, foo runs, prints out hello, it increments x, and then we come back to foo's done, and we print out x, and x is now 2. The scope of x is this entire package, right? So that's just like the first step, kind of looking at scope, the scope of x. And we'll do code here. And we'll call this one scope of x. There we go. So that's one thing. And we could start to narrow scope a little bit. And so if we wanted to, instead of having x way up here, we could do this. And this is going to cause an error in the program because this x is now it's like, I don't know what you're referring to. So if I take that x out of here and run it, now we have, right, x, and x is 0, and then it's 1, and then we run foo, and then we get 1 again right here, so we don't really need that. So we'll just take this code here and run it and save it and share it as a scope of x narrowed to func main. Okay, so we just narrowed the scope of x to func main. And even inside of func main, we could just have curly braces, a new code block, and we could do var y int and y++, or better yet, y : equal 1, format print line y, right? And then we could run that, and we'll make this one 42 so we see a difference. And so y just printed out right here, but we could not print y right here because it's undefined. The scope of y is only in that code block. So you could have a code block inside a code block and just have it be limited. Just kind of interesting. And I'm going to comment that out so that, you know, code block in code block. So you can see that. And then the next one is like, okay, so this idea of being aware of the scope of our variable. Where is our variable living? So that we don't have variables all over the place that we're accidentally overriding or accidentally calling and getting the wrong value from. We want to keep our scope as narrow as possible. So closure allows us to do that. And you can see here that you can kind of say in some ways that, you know, this code block is closing over y, and it's limiting the scope of y right to there. Okay, so let's look at an example of using closure that's a little bit more realistic. And to do that, I'm going to do a function, and this function, I'll do it down here. That's the way I've been doing it the whole program. Func foo is going to return a func that returns an int, and we'll do that. And we'll call this incrementer. This is the example I wanted to do. We'll call this incrementer, and that's going to return a function. And so we need to return a function. So we're going to return a function that returns an int. That's our return. And now here is that function. We're going to define that function that gets returned here. And when we do that, we're going to create a variable here. And this variable will be var x int. So we're setting it equal to 0 value. So x is of type int and the value is 0. And so when incrementer gets called, this variable gets set. This variable is only going to live from here to there. But notice it also lives inside this function. And so inside here, we can now go x plus plus, and then we could return x. Because what this function does, right, is this function is going to increment x and then return x. Do we need to pass x in as an argument to this function? No, because the scope of x is all right there. And so it has access to x right here. So we increment x, we return x, and that returns the number that's been incremented. Okay? So now let's call incrementer. And we're going to assign incrementer to a variable a. And we're calling it. So when we call incrementer, incrementer runs. The variable x is set to the 0 value of 0, and it's of type int. Cool. Just making sure I press record. Sometimes I just start talking. And then it returns this function, which is enclosing its closure around that x, right? And it returns that function, which has, it's like, storing variables in that x, storing a number in that x. And then this function will do these things. So there's that function that gets returned, a. We'll also do it with b. We'll assign it to b. And now we will call a and get the value. So a is a function. It's this function right here. So we are going to call it and get the value. It's going to return that int. And we'll do that a couple times with a, and then we'll do it a couple times with b. That's too many times with b. Let's do 2. That way more of our code is on the screen. Cool. Format it all and run it. And so incrementer runs. It returns this function. And this function, is assigned to a. So that function's assigned to a. And then we come down here and run a. So when this function runs, it takes x, which is 0, increments it to 1, returns that 1. That 1 gets returned right here and printed. We run a again. Well, x is out here, and it is now 1. So we increment it. It becomes 2. We return that 2. That 2 ends up right there, and we print it. 2, 3, 4. And we call incrementer again. It runs again, creates a new variable x. The scope is only right there. Returns this function assigned to b. That is a different variable than the one that was created here. When we call this one, you get a different x than when you call this one, right? Each of these give a different x. Even though they're the same identifier, they have different scopes. They have different memory locations where that value is stored. And then, we return the values. So that's pretty cool. And that's closure. You're using a code block to enclose the values of variables and keep their scope a little bit more narrow. And that's kind of a nifty little way to use closure to create an incrementer, which you could call over and over again. And each time, it's got a new variable x where it's storing the values. That's closure. Just an FYI, right? Like, this is stuff that's good to know about and that not a lot of books or people explain very well. And so I just want to make sure that, hey, closure, no big deal. It's just like a code block enclosing some variables. And this is an example of it being used. So I'm explaining some of these concepts just because I think that a lot of times they aren't explained well, and I want you to have an introduction to them if you've never seen them. Where the introduction is, in my opinion, is a way that's worked, that I've refined and has worked well for a lot of other students. So I hope it works well for you. That's closure.